Okay, good afternoon. So let us continue the lesson. Today there is no new lesson. I will give you some examples to solve together, okay? To practice what we have learned so far about algebraically finding the solutions of a system. Okay, so I will write some. Let me write first one and solve it together, okay? For example, I want to solve this system of equations. I have 3x plus y equals to 1 minus y. And the second equation is 5x plus 2y equals to negative 4x, negative 10y, and then positive 3. So we want to solve this system. So, because you already know what is the meaning of solving the system and things like that, so I just try to focus to this session on how to do the details. Okay, so if we want to solve this system, this is a little bit non-standard system because it is not simplified yet. So if you want to start solving this, I recommend you first try to simplify this algebraically, and when everything is simplified in its simplest possible form, and then you can start solving it using the tricks that you have learned. For example, here I would write the system in this form. So what I write in blue is considered to be parts of the solution, yes? So I multiply this 3 in, so it becomes 3x plus 3y equals to 1 minus y. And here, of course, I know. Let me just simplify them one by one. It might be better. Yes. So here I consider the first one only. So then I multiply 3 in, so it becomes 3x plus 3y equals to 1 minus y. And then I move this unknown to the left and collect it with that term. So this becomes 3x. I have 3 y's here, positive y. It becomes 4y. What is left on the other side is 1. So this is the simplified version of the first equation of this system. I go to the second one. So here I have 5x, and then I have plus 2y. Then I move these two unknowns to the left, so it becomes plus 4x plus 10y. But I prefer to keep 3 on the right hand side, so as it is. And then I simplify to 5x and 4x, it becomes 9x's, and then I have 2y's and 10y's, so it becomes 12y's, yes? On the right hand side, I am still left with 3. Of course, I can stop there, but I prefer to go a little bit further, because you see this number 9, this number 12, and this number 3 are all divisible by 3. So even though you can stop there, but I prefer to continue and divide everything by 3. It is not mandatory, but it makes the problem simpler. So then it becomes 3x, and it becomes plus 4y. On the right hand side I will have 1. That's a little bit unfortunate. The first system is like this. Okay, so that is not what I expect for the first example. Anyway, it is not wrong, but it was better not to have face this one. Anyway, so I have two systems, but both the equations are the same. So what does it mean, by the way? That is one equation, and that is the other equation. So how many equations I have? I have 2 equations, but both of them are the same, so actually they are identical. So what is your interpretation before solving anything, actually? So I think for these special cases, geometrical point of view is very good. So if I ask you to draw the graph of this, what do you expect to get? What do you expect? It's a straight line, yes? And that would be exactly the same straight line. So I have 2 lines, but they lie on top of each other. So how many intersection points we have? Infinitely many. So that's a little bit unfortunate because of that. So this is a system consisting of infinitely many solutions. Okay, in that case, if I want to find all of them, what can I say? I can say that, for example, I can calculate y in terms of x. It doesn't matter if I use this or that because both are the same. So here, let me make y alone. So this becomes 1 minus 3x. Then I divide everything by 4. Then y becomes 1/4 plus 3/4 and then multiplied by x. So you see, this tells you that x is an arbitrary. So let me write as an answer here. If you want to answer this question, you would say that, what is x? X is any number that you like. X is an arbitrary real number. You see, because when I ask you to solve the system, I am asking you find all possible pairs for which both equations are simultaneously satisfied. But actually there are no two equations, because after simplification we realize that there are actually one solution. So it means that x can be any number that you like, but whatever you choose for x, y should follow this rule. This is what I expect you to write as the answer. X is an arbitrary real number, but y should follow that x. So for example, if I choose x equals to 0, it is possible, but when I plug 0 here, y becomes 1/4. So for example, 0 for x and 1/4 for y is a solution for this system. I can change my mind. For example, I can choose x equals to -1. And when I plug -1 here, it becomes positive 3/4 plus 1/4. It becomes 4/4. It becomes 1. So that is one solution. That is another solution. How many of these solutions I can cook up? Infinitely many for each choice of x. So sorry, but that's a little bit unfortunate that the first example is that. But anyway, is that understandable? Okay. Let me try to do. Okay. Let me write one more. Number 2. I have 8x equals to 5y, and then I have 13x equals to 8y plus 1. I want to solve that system now. Okay, I want to hear from you, okay, rather than I start doing it myself. So what is your opinion? You have a system consisting of 2 equations in 2 unknowns. So what is your opinion about how to start solving that? Then what is the main strategy if you want to solve a system? If you remember, for these simple systems, I gave you two methods. One of them was substitution or elimination method, and the other one was addition method. So elimination method works not only for these simple ones, but for many, even for complicated ones, but addition rule might be only for these cases. I don't know which one do you prefer, but tell me what to do now. There is no best way, you just say start doing something. Yes, Sergey? You want to say something?
Oh, I was just thinking that first I would get y to the other side to the left.
Yes.
And then the top equation would be equal to 0.
Yes.
And then I can use the addition method.
Addition method. Okay, I can follow yours. That was not my intention, but I can follow that. So what Sergey is mentioning is that, okay, I move the other one. So I would write it as 8x minus 5y equals to 0. And then, do you want me to move this to the other side as well?
Well, I guess, yeah.
Yeah, okay. So 13x minus 8y equals to 1. So this is the way that he has chosen to start. Okay, and then if I want to use addition method, so if I want to use addition method, do you remember I have to get rid of one of these variables by multiplying them by some appropriate number so that when I add them, they are cancelled. If I just start adding them right now, none of them will be cancelled because this becomes 21x, x is left. This will be minus 13y, so that's left. So first of all, you need to target one of these variables to get rid of. Which one, for example, do you prefer?
Y.
Y is better because the numbers are a little bit smaller. So I want to get rid of y, so I have to adjust the numbers. So if I take and multiply this by 8, I will get some 40 with negative sign here. But if I want to get 40 with positive sign, I multiply it by minus 5. Yes? So what I get in the first equation, I get 8 times 8, 64x minus 40y equals to 0. Then multiply that, 5 times 13, 65 with a negative sign. And then it's plus 40. It's exactly what I meant, actually. And then this becomes a negative 5. And now addition method actually works and is very nice. So if I add them now, what happens? I have 64x minus 65x. It becomes minus 1x, but I don't write 1, I just write minus x. And then this 40 and minus 40 are gone. On the right hand side, I have 0 plus minus 5, which is minus 5. And then immediately I get x equals to 5, yes. So x is equal to 5, and then you can use this or that to find your y variable. So if you don't mind, let me go and plug this here. It's easier, isn't it? So I put it here, so it becomes 8 times 5 is equal to 5 times y. And I want to make y alone, so I divide by 5, so it becomes 8. Then this means that y is equal to 8. So this system has one unique solution, and that is x equals to 5 and y equals to 8. Yes? You might prefer to use substitution method. That's also working. For example, if I want to use that, I have to make x or y alone. So I can divide everything by 5. So y becomes alone 8 over 5x, and then I put it here, and then becomes an equation in one unknown and solve it. It doesn't matter which method you use. You can usually use what is better with that problem. Okay, so let me try to see if you can manage solving these. Okay, so number 3. So what is your opinion about this? I would rather to give you a little bit of time to think about it yourself, okay? So I have x, a system is a little bit lengthy, so it's x plus y divided by 8, and then I have plus x minus y divided by 6 is equal to 5, and then I have x plus y divided by 4 minus y minus x divided by 2 is equal to 10. Okay, so if you don't mind, let me give you some time to think about this yourself. Try to do it yourself. And then, after you are done, I come back and solve that. The people at home, because I want to pause recording, then you will not be able to see the system anymore. So I give you a little bit of time. If you are interested, take some notes from the question. Then I pause the recording. Okay, I hope that you heard me, yes? The people at home, if you are interested to work, please take a note from the question. As soon as I press the pause button, you will not be able to see it anymore. Yeah, please take your pen and paper and do the problem. Just don't think it in your head, you know? Okay, I pause the video now. Did anyone get the correct answer? Do you have values?
Yeah.
Yes, what is x and what's y?
X and Y are both 20.
20. How many of you agrees? Okay, so apparently it should be right, but let me just do it in case some of you don't have the answer. Okay, for the time being I can keep it up there. Okay, so can you tell me how did you do it?
So I began by getting rid of the fraction.
Exactly, that's my impression as well. So I want to get rid of all the fractions here, so I have to rescale the equation. What is the best number?
24.
24, yes? Don't multiply by 48. 48 also works, but it is unnecessarily big. Yes? So you just multiply everything in this equation by 24, not because of addition method right now, because we want to get rid of fractions. If I multiply by 24, 24 in your head divided by 8 is 3 times. Let me write all these steps. 3 times x plus y. And then I will have plus 24 in my head divided by 6 is 4 times. So I have to multiply this by 4. And then 5 times 24 is 120. So if you don't mind, let me simplify this as much as I can. So I multiply 3 in. And I multiply 4 in. And then I start simplification. 3x plus 4x is 7x minus y is equal to 120. So that is the simpler version of the first equation. And I will do the same thing. We want to get rid of the fractions here, so the best number to multiply by is 4. Alright, when I multiply this by 4, I can do it in my head. 4 by 4 is 1. 1 multiplied by that, I don't need to write 1 times that. I just simply write x plus y. 4 divided by 2 is 2 times. I have a negative sign. I have to be careful. Y minus x. And I'm multiplying this by 4. So let me just write it here. I get this. This becomes 40. And then I simplify it a little bit more. So this becomes x plus y minus 2y plus 2x is equal to 40. 2x plus x is 3x, and then I have minus y equals to 40. So far I haven't started solving the equation. What I have done, I have reduced my system to a simpler system, to a simpler equivalent system. Because that's very important. The system should be equivalent to the one, otherwise I get different answers. Okay, so I just ignore the system, I just work here. Which method do you prefer here?
I use addition.
Addition is better, yes? It's a minus y, minus y. To get rid of minus y, I multiply this just by minus 1. Let us do it in our head, both cases, yes? I multiply this by minus sign, it becomes minus 3x. Addition method, I am adding it here, so this gives me 4x. Hopefully you understand what I said orally, yes? And then minus 1 multiplied by that is positive y. When I add, they are gone. Minus 1 multiplied by 40 is minus 40. When added here is 80. So as your answer is completely right, so x becomes what? This one divided by that one is 20. And then I plug it back. You can plug it back into the original system, but it is not very efficient. So I would prefer to put it here. The numbers are smaller. So 3 times x is 60 minus y is 40. I move 60 to the other side, it becomes minus 20. Minus y is minus 20, so y is 20. So this means that you need to write the answer. X is equal to y is equal to 20. This is somehow, you can also write it something like this if they are equal. Okay, I will write 2 more here for you, and then wait for you again. Any questions regarding them? Is that clear? Okay, good. So let us move this up. Yes, as I told you, let me write 2 here for you. Number 4 and 5. This one, let me make the numbers a little bit unusual. So I would write 3 square root of 2, and I want exact values. X plus 2y equals to 8, and then I have square root of 2x minus y equals to 1. This is very simple. The reason I just want you to get used to how to work with certain signs if necessary. And number 5, let me write it here. And I want you to solve that one as well. There is no hard part here, so actually. So 1, you need to do a little bit of algebra. Okay, I wait a little bit more. After you've thought about both of them, then we can start. Okay, the people at home, the same thing. If you are interested in working on your own, please take notes from these equations. As soon as I pause the video, you will not be able to see that.
So is that 3 square root of 2x?
Yes. 3 square root of 2 is the coefficient of x. Okay, I will pause the video now. The people at home, hopefully you have time. You had time to find. Okay, is the number 4 finished?
Yes.
So what is your answer? Yes?
X is square root of 2 and y is 2 times square root of 2 minus 1.
Yes? Is that your solution as well?
No, I got y is 1.
Y is 1. You got y also 1. So let us check. Okay, at least I can hear from you which method you want to choose for me here.
I multiplied the second one by 2.
So you have to, yeah, I think I also do that because I want to use addition method, yes? It is better. So if I do that, let me write this. I will write it below here. The first one is the same, so let me just repeat it. But then I multiply the second one by 2, so this becomes 2 square root of 2x, and then minus 2y equals to 2, yes? And then as you said, I add them, and then you immediately realize that this one and that one when added are gone. But then what can you write for this?
5.
5, because I have 3 square root of 2x, 2 square root of 2 more is added to that. So it becomes 5 square root of 2x is equal to 8 plus 2 is 10. Yes? And then I want to make x alone, so I divide by the coefficient. But the coefficient is 5 square root of 2. Of course, in principle, you can stop here and say, try to sell this number to me. But I would prefer to be able to simplify that, because that is the number, that's correct. But I would prefer to continue, and as you mentioned, x exactly is the square root of 2. Why is that? Because, first of all, I simplify this 5 here. 5 divided by 5 1 times, 10 divided by 5 2 times. So I will continue and write this is only 2 is left in the numerator and only square root of 2 is left in the denominator. Of course, this is simpler than the previous one, but still you can simplify it even more. Yes? Instead of 2 in the numerator, I don't know how do you want to simplify it, but one way to look at it is to write the square root of 2 multiplied by another square root of 2. If I ask you what is the square root of 2 times the square root of 2, it becomes square root of 4, which is 2. So I have done everything right. But then what is the benefit of doing that is that one of them will be simplified even more. So then what is left for me is the square root of 2. And I hope that you agree here is a good point to stop rather than in this strange 4. So everyone agrees that the square root of 2 is a better name for a number than 10 over 5 times square root of 2. Yes, is that clear? But I told you that in principle, I want you, because the people who can write this, they deserve more points in the exam as well. Okay, and then I have to go back either to this equation or that equation, whichever you prefer, but I think probably the second one is a little bit easier, isn't it? The numbers are smaller. So I replace x with the given value, with the value that I got, so it becomes 2 square root of 2 instead of x multiplied by square root of 2, and then I have minus 2, and then I have y equals to 2. But there is a better name to write this. What is that one? Square root of 2 times square root of 2 is 2. Another 2 here, so it is just 4. Then it becomes 4 minus 2y equals to 2. I move 4 to the other side. And then I make y alone, so as Oscar mentioned, so that answer is correct. So the answer to this problem is x equals to square root of 2 and y is equal to. And that is the unique solution for this system. Yes? So you might make mistakes.
Yeah, I saw my mistake. I put in 2 instead of square root of 2.
I don't know, in the meanwhile, do you want to give you extra time for 5, or you have already done 5 as well? You haven't. So I just let me, the people at home, please take note if you want from number 5. I will pause recording, wait for you a little bit. But let me, in the meanwhile, I add one of these with search signs a little bit harder. So if you have already done number 5, don't waste your time. Just jump to number 6 here that I will write. I have to write it in a way. Okay, I can write it there. So this is the same idea, but a little bit harder. So you need to work a little bit more algebra. Okay. Now, give you time to write it down at home if you like to. You can start 6 now. Okay, now I pause recording the video. Okay, how many of you have answered question number 5? The one that I haven't solved yet, this one. Except others? Question number 5. What is the value for x? What's the value for y? Okay. So what is your answer, Simon? You told that you have the answer.
for question 5, x is 0.25 and y is 5.75.
Okay, so it is 1/4 and then
5 3/4.
yeah, 5 3/4. Yes. Okay, what about others? Do you agree with him? Anyone else? Okay, let us try to solve that one as well. Okay, at least can you tell me what is your first step to do this?
Okay, so my first step was, this might be the dumber decision, but I took the first equation and tried to simplify it as much as possible.
So how? Yes, you are right.
So
But in this, which way? Are you moving or multiplying?
I multiplied the whole equation by 6.
Yeah, that's the best choice. Let us just follow you. So the first equation you see up here, I want to get rid of these two fractions simultaneously, so I multiply by 6, and let me just do it in my head. When I multiply this by 6, the 6 that I am multiplying and this 2 will simplify, 3 is left. So this becomes 3 times 1 minus x minus y. And then when I multiply 6 here, 6 that I multiply and these 3 are cancelled, 2 is left, 2 is multiplied there. So it becomes 2x minus y minus 2. You can also use this trick. You remember I told you that if you have two fractions equal, these are called the extremes, these are called the means. So the product of extremes is equal to the product of means. So that's the same thing, always, yes? But then I want to simplify it still more, so what I do, I multiply 3 in, I multiply 2 in, and then I don't know what you have done. Might be you have moved the x value and y to the one side and then the numbers to the other side. Yes, might be. So then this I have minus 3x here. I move 2x. It becomes negative 2x, so it becomes negative 5x. I have minus 3y's here. I move this to the other side. Positive 2y minus 3y minus y. On the right hand side I have minus 4. I move 3 to the other side. It becomes minus 3, so it becomes minus 7 overall. And then because I have a minus sign here, minus sign here, minus sign here, let us multiply by a minus sign to write all of them positive. Of course you can keep all of them with negative. I don't know which one is useful at the end. Okay, let us for the time being multiply everything. Might be we have to multiply these things back anyway. Just keep it like this. Okay, and then I think multiplication by 6 will also work for the second one, because I want to get rid of all fractions. So I multiply the left hand side by 6, the right hand side by 6, and I do simplifications. When I multiply this by 6, 3 is left, 3 multiplied by x, so it becomes 3x. I multiply this by 6, 2 is left, 2y with a negative sign. When I multiply this by 6, 2 is left, 2 multiplied by x. And I multiply this by 6, 3 is left, multiplied by y. And when I multiply the last term by 6, I get positive 6. It's the best way. So I move this to the left. 3x minus 2x is just simply x. I move this to the right, to the left. It becomes positive, and then it also becomes positive. Yes? So, yes, that's correct. And then what is left for me there is 6. Then I write this. So far I haven't started solving the system. I have just simplified equations in my system. One of them is 5x plus y is equal to 7, and the other one is x plus y is equal to 6. You can use method of elimination here or addition. So let me just use method of addition here. If I multiply this in my head by minus 1, this y and that y will be opposite. So let us just do it in our head. Minus 1 times x is minus x. I add it here, it becomes 4x. Minus 1 times y is minus y. I add it here, it is totally gone. Minus 1 times 6 is minus 6. When I add it here, it becomes positive 1. So what the answer you got at for x is so far correct. X is a quarter. And then you choose one of these equations, or even the original ones, but of course these are simpler. I put here, and then I get 1 over 4 plus y is 6. And as you mentioned, this is 6 minus a quarter. If you want, you can write 23 over 4. Or if you want, as you mentioned, I can write it 5 and 3/4. So the answer to this problem is x equals to 1 over 4 and y equals to 5 and 3/4. Of course, in this case, because the values are exact, it doesn't matter if you use decimal points. Writing 0.25 here and 5.7 is 5 there. That is okay. But if the values are not exact, you have to keep in the fraction form. So thank you. That was correct. Is there anyone that you got that got the answer to 6? Okay, let us see who one else. Who else did number 6? If you are in the middle of way, I can give you extra time, but do you think if I give you extra time, you can solve it? Can you raise your hand? How many of you have done number 6? Only one? Okay, so I will give you a little bit more time, okay? I pause recording, so yeah, please again, people at home, if you want to take notes. Okay, let me again do the same thing because I don't want to waste the time. So I will write another one here. So if you have already done 6, don't waste the time and try to think about this one as well. So number 7, let me write number 7 here. I would write this system now. So 1 over 4x plus 1 over, this is the first time that you see a system in which the unknown appears in the denominator. But it's not hard. You know what to do probably, okay? Okay, so if you've done number 6, don't waste the time. Immediately go to number 7. Okay, now I pause recording. Okay, what happened to number 6? No more? No more people? Okay, can you read, Simon, you said that you solved the problem?
Yes.
Can you read your answer for number 6?
X is equal to 6 times the square root of 5 and y is equal to 5 times the square root of 3.
Okay, so let us check. Yeah, but the answers are reasonable probably. Let us see. So, what is your first step to solve this?
Okay, so my first step was at the lower equation. I multiplied everything, the whole equation, by the square root of 5 and square root of 3.
So in principle it means that you are multiplying everything by square root of 15.
Yes.
Because you are saying that I multiplied by square root of 3 and square root of 5, so it means that you are multiplying by square root of 15. That's correct. But when I multiply square root of 15 here in my head, I can divide square root of 15 by square root of 5, which will be square root of 3, and I multiply square root of 3 here. So I'm just working on the second equation. And for the same reason, if I multiply this there, what happens? It becomes square root of 5 when simplified. So it becomes square root of 5 times y equals to 1. And now, if you don't mind, let me bring this down and write it below. It doesn't matter if you're writing the first or second, it doesn't matter. So let me just write it here. I do not have enough space on top.
Babak.
Yes? Oh, yes. Square root of 15, because I am rescaling everything. Thank you. When I multiply the left-hand side, I have to multiply the right-hand side as well. So then it becomes 29. Okay, then what is your take on after that?
So once I have that, I move the 7 times square root of 3 times y to the right and move 29 to the left. So then I simplified it so that y gets alone on the right hand side.
Okay, so you want to use the method of elimination.
Yes.
Let me see, is that a good... Yeah, that's definitely working. But is there any way to get rid of... So make it a little bit simpler? Might be not. Okay, so Simon is using method of elimination. That is completely right. He's saying that I move this to the right side and then to the left side. But then, of course, you have to divide by 7 square root of 3. It becomes a little bit nasty and ugly, yes? But let me see if there is a way to do that. First of all, let me try to get rid of this part. Okay, can you tell me what should I multiply here and there so that when I add them it is gone? Is it clear? Yes?
Square root of 15 in the second one, and negative 7 on top.
No. If you multiply square root of 15 here, it becomes square root of 45. Yes?
Oh yeah. Oh.
So this is a square root of 5. This is a square root of 3. So first of all, don't worry about 7. You want to make them the same with different signs. So let me multiply this by square root of 3. Why this is good? Because this will give me square root of 15 here. To make a square root of 15 here, what do I need? I have to do it step by step. I myself cannot guess immediately. So the square root of 3 that I multiply will make this a square root of 15. This number that I multiply will make it a square root of 15 so far. But the point is that I have a minus 7 here. So let me write it minus 7 there. Now do you agree that this is working? Let us check. Because this is a little bit hard, so let me just not to do it in one go. So let us do it. I am claiming that if I multiply the first equation by this number and the second equation by that number, I reach my goal. Let us check. Can you do it in your head? If I multiply this number by square root of 3, can you do it in your head? What's the answer?
Minus 21.
Minus 21, because the square root of 3 is 3 times that one. It's minus 21x, thank you. And you see that I am avoiding working with the square root signs. And then let me multiply this by that. Can you tell me what should I write? First of all, positive or negative? Positive. Negative here, multiply positive. 7 square root of 3 times the square root of 5. What can I write? 7 square root of 15 and y. And the other side, can you help me to write it? Minus square root of 7 square root of what? 45. Is that understandable for everyone? Yes. Now let us go to the next one. Do it in your head. Square root of 5 times 5 square root of 5. What's the answer? 25, yes. Because the square root of 5 is 5, another 5 is 25. I'm multiplying. And then this one multiplied by that one becomes negative 7 square root of 15 y. And then I multiply this by the last one is 29 square root of 5. So I reached the goal. Do you agree? Because when I add them, who cares about the nasty looking here? It's gone. And then this one and this one is very innocent number. It's 4. Yes, so it's 4x. But I want to wait for you to tell me what to do with this. Because if I want to do it right now, there is only one way that I can do. I can write minus 7 square root of 45 plus 29 square root of 5. And I cannot go any further. Because square root of 45 is not the same as the square root of 5. And this is really ugly. Sometimes it is inevitable, we have to work with ugly numbers, but sometimes we can find a way. Do you think you can simplify this more? To make it more beautiful? Look here. Square root of 45 can be written in a little bit nicer way. Yes, Sergey?
16 square root of 5 plus 29 square root of 5 would be equal to...
So 16 you said?
Yeah.
I didn't understand what 16.
Basically, I think 36 square root of 5.
30x. No, let me just, might be you are making some mistakes. What do you think about square root of 5? Do you have any idea what to do with the square root of 5? The square root of 45?
It's square root of 9 and square root of 5.
Yeah, that's correct. Okay. So what you are saying is correct. I don't know why did you make that conclusion. So you are saying that square root of 45 is a square root of 9 multiplied by 5, but square root of 9 has a better name. What is that? 3. So it's 3 square root of 5. But here you are multiplying minus 7 here. So what's the answer here actually? Minus 21. Okay, now I understand where you brought 16. That's correct. Sorry, that was my mistake. Oh, sorry, I made a mistake here. That's fine. Is that understandable for everyone? There is another name for this number. I can write it in this form based on this argument. I have minus 21 square root of 5. I have 29 square root of 5. What is left for me? What is left for me? 8 square root of 5. Agree or not? And then everything is simple. I want to make x alone, so I divide by 4. Do it in your head. What's the answer? 2 square root of 5. And that's exactly what you got, Simon. But I think it was a little bit more work. Yes? So it's not hard to master these tricks. You see, I couldn't guess myself, but I did it gradually. Yes? Okay. So x is 2 square root of 5. And then what is your opinion about where to plug in? This is the first time. You can plug it here, plug it there usually, but I prefer to plug it here. Do you agree with me?
Yes.
Why? Don't be actually very rigid-minded, you know. Usually I tell you to put it here, but this is clear that if I put it here, it's simpler. Because I am dividing x by square root of 5, immediately I get rid of this square root of 5. It doesn't matter if you want to put it here, or put it there. But then here I prefer to put it here. So instead of x, let me just write everything. So 2 square root of 5 divided by square root of 5, and then minus y over square root of 3 is left equals to 1. And then whatever square root of 5 is, it's cancelled. And then what is left for me is 2 minus y over square root of 3 equals to 1. Let me change my strategy. Usually I rescale, but let me not do that. So I move 1 to the other side. 2 minus 1 becomes 1. I move this fraction to the other side. Then I rescale. And then immediately I get y is equal to this. So now I think that, was it your answer, Simon, or is this one also your answer? Both of them? Ah, good. So at least you see that this is the correct solution. Any ideas? Any problems here? So you see, there are different ways to tackle the problem. If you solve more problems, you get more experience in solving the problem. Any questions? I don't know if you have any idea about number 7. So, yes, Oscar?
Well, I think I found it.
Okay. But tell me what is, so I don't know how many of you have have started working on 7. I can give you 5 more minutes if you want to work on number 7, and then come back and solve it. Okay, the people at home, if you haven't taken notes from number 7, you can do it right now after 15 seconds. I will pause recording. Okay, now I pause recording. Okay, because some of you have already solved the problem, let me solve a little bit hard problem, the masterpiece for today's session. And then if you have already done, you can work on this problem as well. So, this system, I have 4 over x plus y minus 1 minus 5 over 2x minus y plus 3 plus 5 over 2 equals to 0. And then I have 4 over x plus y minus 1 plus 1 over 2x minus y plus 3 plus 7 over 5 also equals to 0. So this is number 8. And yes, if you have already done number 7, don't waste the time. Work here as well. Okay, I pause recording the video. Okay, let me at least solve one of them for you, because there is some point in number 7. I don't know, might be you have already been able to solve number 7. How many of you could solve number 7? What are the answers, Oscar?
I got y to 1/2 and x to minus 4.
1, okay. But I don't know, how. Can you tell me how did you do that?
I inverted the fraction.
Can we?
Can we?
That's a good question. Can I invert them? So let me first make sure that I understand you right. By inverting you mean, let me have this in my hand. So by inverting you mean reciprocal, yes? So it means that you write 4x over 1 and then plus 3y over 1. Then instead of 2 you write 1 over 2. Is that what you mean?
Yes.
But this is illegal.
Okay.
Yes? Why is that? Let us check. Do you agree with me that 2 plus 3 is 5? If the inverting process or writing the reciprocal is going to work, it should always work. Yes? So then it means that if I write the reciprocal plus the reciprocal, this should be 1 over 5. But this is not true. Because 1 over 2 plus 1 over 3 is 5 over 6, and 5 over 6 is not equal to 1 over 5. The one that you are mixing it up with, I think, is this scenario. If I have this, then of course you are right. I can write it like that. But not for addition or subtraction. So that's a crucial thing. That's good that you brought it up. Thank you. So this is not valid. So be careful. This is not that simple. But then there is an idea I want to teach. I think, I don't remember exactly. I think I told you some trick like this before in Math 1C under this name. I don't know how many, auxiliary variable. I don't know. Do you remember something like that I talked about? I think I did, but anyway. So auxiliary means something that helps you. Yes, it's not that necessary. So let me tell you what to do. This trick, this is something that appears in a lot of places to simplify things for you. I will teach you this now, not because this is a new lesson. You know, the lesson of systems is finished. I am improving your solving skills, your problem solving skills. So here, let me tell you, I will say that let capital X be equal to 1 over X and capital Y be equal to 1 over Y. So you need to be a little bit patient. What I am doing right now might be not clear for you right now, but it becomes clear at the end. And then you have to take on lessons for you. There is a take on lesson for you, and then to remember this trick. Okay? So you see, if I ask you what are the variables in this problem, you say little x and little y are the unknowns. But because of the form of that system, it is suggesting me somehow to bring in some helping variables, some auxiliary variables. I introduce capital X to be 1 over X. I introduce myself Y to be 1 over Y. Why this is useful? Because now, if you look at system number 7, let us do some scratch work here. 1 over 4X is equal to 1 over 4 times 1 over X. First of all, is that understandable for everyone? Okay. But now, if I give 1 over X another name, capital X, then I can write it as 1 over 4 capital X. And then let me look at the other one, 1 over 3 over Y. I hope that you agree with me that I can write it as 1/3 times 1 over Y. But I have introduced capital Y to be 1 over Y, so this becomes 1/3 capital Y. Okay? Now if I write, just be patient a little bit. Now let me rewrite this equation, but instead of my original variables, little x and little y, let me write them in terms of capital X and capital Y. So then what happens? The first equation becomes 1/4 capital X, and then plus 1/3 capital Y is equal to 2. Okay, can you help me without explanation? Can you help me how the second equation will read by this trick? So what will 1 over Y becomes what? Capital Y, and then the second one becomes -1/2 capital X is equal to 1. Now something very nice happens. In this system, the reason that you couldn't solve it right immediately because these unknowns appear in the denominator. Now, if I ask you to solve this system, do you think you can solve it? Because that is a very standard system. What are the unknowns? Capital X and capital Y. So, momentarily, forget about the original system and focus your energy to solve this one, to find capital X and capital Y. And then when capital X and capital Y are found, you put them in this very simple equation and find little x and little y as you demand. Yes? So what I want to do here, I want to get rid of all fractions. So what I do, I multiply the first one by 12. this becomes 3 capital X, this becomes 4 capital Y, this becomes 24. I multiply everything by 2, 2 capital Y minus little x equals to 2. Yes? And now I use method of addition. If I multiply the second one by another 3, this becomes minus 3x plus 3x. Of course, if I have foreseen that, I could have multiplied by 6 in the beginning, but now I can multiply it by another 3. So then what happens? Let us do it in my head. 3 times 2 is 6y. When I add it here, it becomes 10 capital Y. When I multiply this by 3, negative 3x by this one are gone. When I multiply this by 3, it becomes 6 plus that one is 30. But the capital Y is now found to be positive 3. What I do now, I put it back in one of these equations, which is simpler. 2 times capital Y is 6. I move it there, it becomes minus 4. So capital X is 4. But should I stop here? No. Because I was not looking for capital X and capital Y. These variables were not in the problem in the first place. I want to find little x and little y. Okay, what I do, I would say that, okay, capital X is 4. This means that 1 over x is 4. Now, if I ask you what is little x, that is 1 over 4. By the way, what was your answer? What was your x? You got it with the wrong method?
Negative 1/4.
Ah, this is positive 1 over 4. So the correct answer is positive 1 over 4 for x. And what about y? Capital Y is 3, but what is capital Y? Capital Y is 1 over y is 3, so the reciprocal of y, the y itself is 1/3. So these are the answers. So sometimes, please remember this, sometimes an equation is a little bit more complicated, but if you are smart enough to look closer, you can find new variables so that if you introduce to the problem becomes a standard one. And you solve that and find the intermediate variables, and when they are done, you go back and find the original variable. This
I have a question.
is actually very popular in different parts and areas of mathematics. So you
Babak.
bring in some new variables, try to find those new variables. You need, of course, this is not always possible, but this is a very good practice. If you are interested student, you should go home and solve this problem using this trick. This problem looks a little bit horrible. If you want to manipulate the denominators, take the common denominators, it takes a while. But if you look closer and you have digested this method, you immediately can introduce 2 new variables in a way that this horrible system looks manageable. And then when you find those capital letters, you can use your introduction, how you introduce to find your little old variables.
Could I ask a question?
Excuse me?
Yes, I have a question to 7. I tried to...
I can barely hear you, so please go on and speak a little bit.
So I didn't realize that we could do this thing with the substitution, just solved it by brute force. And anyway, it was wrong. But when I checked in Desmo or in GeoGebra,
yes,
you could see that there should be 2 solutions for it.
I don't know how should I hear you because the quality of this is very bad. Okay, let me open the doors. Might be I can hear you better. Okay, Rasmus. So what did you say?
I checked with GeoGebra, and
yes,
shouldn't there be 2 solutions to this system?
No.
Or I checked.
So what is the other solution? Can you see?
It should be 0. It should be 0. X and Y should both be equal to 0.
No, this is not possible. Because
Oh,
see
yeah,
that
wait.
if x is equal to 0,
Oh, yeah,
the
that's right.
system is not defined in the first place. But if you naively get rid of the fractions, then of course 0 and 0 will be a solution, but a solution to the system that you get after multiplication, which is not equivalent to system number 7.
Yeah, I did not realize that.
Yes, because when you multiply to get rid of these fractions, you are tacitly assuming that x and y are not 0. And of course it is clear this is my original system. The system that you get after multiplying is not equivalent to your system, because the action of multiplying is not reversible unless it is not 0. Yes, so what I got is completely right. This system number 7 has a unique solution, and that is 1/4 and a third. I hope that you could understand what I said.
Yeah, I understood.
Okay, good. Okay, thank you very much. We can end the lesson now. And I really recommend you, after you got home, please think and solve this problem. Tomorrow I will also continue a little bit of more interesting problems, and this is finished. We will continue to the next lesson. Thank you very much. Bye-bye.
Bye-bye.